Let's have a look at example 8. So this one's calculator allowed, so we're going to use the GDC to help us do a lot of our calculations. A portion of the graph f of x equals x sine x is shown. Find the area of the shaded region. Okay, so let's set up an integral for this. So rather than just getting a single answer from the calculator, you should set up your integral every time, even if you can use a calculator. So I want the area from, well, let's use the calculator to help us find the boundaries first. So we need to do that. So x times sine x. So here we go. Analyze graph. Okay, so even though we can kind of tell visually from the question, it's always a good idea to confirm. So 3.14. All right, and now that tells me that's probably pi. The calculator just rounded that. So let's snip this bit off. Right now, you can also calculate your zeros by hand really quickly. So if 0 equals x sine x, we have x equals 0, or sine x equals 0. And if sine x equals 0, we can confirm that one of the zeros is pi as well. All right, just knowing your solutions for sine x. All right, so always make sure you confirm your intercepts. So that means I want 0 to pi under the graph of x sine x with respect to x, and then that integral we can just figure out on the calculator. So let's do that. Whoops. So we want the integral, where's the integral? Here. From 0 to pi x times sine x with respect to x, okay, which happens to be pi. So there's our area, and we don't know what the units are, so let's write units squared. Okay, let's do B. Write down the integral representing the volume of the solid form. Okay, so this is a volume of revolution. So the formula is going to be V equals pi integral, so the area that we just found from 0 to pi, and the only thing we need to remember is we have to square our function. All right, so that's the integral if we rotate this area around the x-axis, and we're going to use the calculator to figure that out. So type in the integral again, 0 to pi x times sine x all squared dx. Oh, make sure I put my pi in at the start. Equals 13.77. How many decimal places should we use? Let's just use 3 sig figs. So let's go 13.8. Approximately 13.8. Now it's volume now, so let's use units cubed. All right, so that's example 8. Now let's have a look at example 9. Again, we're going to use that calculator to do most of the hard work. Find the area of the region in quadrant 1 that is bounded by the curves y equals 0.4x and y equals sine x. Okay, so let's graph it first on the calculator. 0.4x and sine x. There we go. Now, we can get the answer straight away here, but we need to at least show some methodology when we're answering this type of question on a calculator exam. So let me zoom in a bit because I'm only interested in quadrant 1, which is my top right quadrant. So there we go. And since I want the bounded area, so the area between the blue and red graph, I need to know where they're bounded, so that's our intersections. So we have one at 0, 0, and so analyze graph intersection, right, and 2.13. So let's go ahead and clip this into the question. Whoop. Here we go. All right, so the area I want to find is this area here, highlighted in yellow, the whole thing. So what we need to show is that we can set this up as an integral, right? So I'll do it here. Area equals, so the integral from 0 to 2.13. Now, remember, area between curves is always the top function minus the bottom function. So top function in this case is sine x, and then take our bottom function, 0.4x dx, right, equals. So two ways we can get this answer now. I'll show both. So we can get it straight from the graph on the calculator. So since we've already found our intersections, let's go analyze graph, bounded area, click point intersection, and then click the other point intersection, and here we go, 0.623. So maybe I just replace the graph with our new graph, and now I can rub out my highlighting. There we go. And let's just type the integral into the calculator as well, just to confirm. So that way you can see that different ways you can get the calculator to help you. So here we go. I want 0 to 2.13. Sine x, take 0.4x, x, 0.623, there we go. All right, and that's how you do example 9, or any other question that requires you to find the area between two curves. All right, just always get in the habit of setting up the integral, even if you are using a calculator to help you get the answer. Okay, we'll see you in the next video.